Okay, hello everyone. I'm Graham, and my talk today is battle-tested Drupal website availability. Waiting for the next slide to load. Oh, hang on. Oh, something seems to have gone wrong. Has anybody seen this before? Or maybe this one. So, about myself, I'm a lead developer at Webcurl. I've been working with Drupal for longer than I care to mention, actually, since Drupal 6. And one of my main responsibilities is managing the hosting arrangements for our customers. So these are not quite all of the LocalGov Drupal councils that we manage the hosting for. So I thought I'd first go through what are we talking about, like website availability, uptime. So it's usually, you see it as expressed as a percentage, maybe in like a service level agreement or something like that. But you know, percentages are really not good for expressing what this means in real terms. So it's always helpful, I find, to go back and look at in what sort of time frame each of these corresponds to. So you have here like 99.9, so that's like 3 nines. So that's equivalent to 8 3/4 hours of downtime per year. So that's generally achievable. You don't need to do anything like too special to get that sort of level, I believe. Or then say 99.95, that's half of the time. So if you're looking at say monthly, then that's like 20 minutes per month. So interestingly, when you're looking at these figures, then they often don't include like time for like scheduled maintenance. So you could theoretically like bring your site down for several hours and still claim to have this level of uptime. I'm not too sure about that practice. We come on to like 4 nines. So these are like much more critical systems. In order to achieve levels as high as that, then you have to start getting into much more complicated architectures and adding like redundancy at every single layer, basically. So you can go on beyond this for like really critical things. It's quite interesting. The air traffic control system, the NATs, then they've suffered some pretty major outages over like, a couple over the last few years. So like with like 3 hours downtime within 3 years, then they were only meeting like 4 nines basically, which they claim was acceptable, but don't know. So that's sort of uptime. Availability, then that is usually seen as a sort of distinct thing. So it also considers more the actual experience that your website visitors are getting. So if your pages are loading, but they're taking 30 seconds, you could claim that the website's up, but people are going to be having a pretty abysmal experience. And also, if certain pages on your site are showing errors, you can get to the home page so the site's up, but critical things on the site are not working, then that has an impact on your availability as well, I'd say. So why is it important to keep your council website up and running? So if it goes down, then customers are going to be frustrated. They can't find the information they need, so wasting time. They can't complete their important tasks. So say you have like payments that are due and you can't do it, and you might even get into trouble for not doing it. Also worth thinking about is the impacts on vulnerable residents. So somebody might desperately need to find information about homelessness or domestic violence, for example. So it's important to make sure that these are always available. And of course, if the website's down, it places extra demands on staff. People ringing up, can you help me with this because I can't do it online? Or even like, did you realize that your website's down? And then there are other impacts as well, like search engine rankings might go down if the crawlers can't get to you. Perhaps content that you've updated recently isn't going to be indexed, so people can't find it. Reputational damage, like this council's website's always down, or loss of confidence and trust. So people might shy away from using your online services because they've had a bad experience and they just go back to the old way of doing things, which is not what anybody really wants. Also, maybe contractual penalties. I don't really know this. Perhaps they're the things that you're required to have on the website, and if they're not there, people can't get to them, then there might be problems. So what are the ways of monitoring your uptime and availability? So there's basically like a twofold approach. First of all, you can simply have a service that is pinging your website regularly. It's loading pages. As I said, like you might want to make sure that they're being loaded in a sensible amount of time. There's things like uptime robots or status cake or various things. Also, a good thing to do with these is to make sure that it's returning the content that you expect it to be returning. I've certainly seen incidents where pages are being served with 200 OK, and you could assume that everything's OK, but it's not OK. It's actually a blank page, and if this happens, then you want to know before customers have to tell you. So that's external monitoring. Also important is like monitoring like the real requests that are going through your system. So you can see the response times for all of the users this way. So perhaps like if I load the website, it looks fine, but there are many people struggling to load certain pages, for example. So we have statistics for this. Generally, you look at like the P99, so the 99th percentile latency. So if something's affecting like maybe 1 in 100, it's an outlier. So maybe this is like particularly expensive operation within the system. So it's more about the 99% that we're trying to care about the most. And also like error codes, so you can see whether your visitors are encountering a lot of errors when they reach pages, and you can do something about it proactively. So here's just an example of a dashboard that we have that shows latency and error rates. Got a heat map that shows like, over time what percentage of users are getting pages at an acceptable level. So I just wanted to add a couple of Drupal configuration tips because that was promised in the talk notes. So the best way to make sure that your pages are responding quickly is to ensure that things are cached. So Drupal has Drupal has many different layers of caching, and if you're developing, it's very important to understand them all to make sure that visitors see up-to-date content. You're not caching things that you're not meaning to cache. So this is making sure that you have the correct cache contexts and cache tags whenever you're building like a block plugin or anything like that. Anyway, yeah. So the internal page cache is it ships with Drupal switched on. It's quite good at what it does. The pages will come back if they're in the cache within like 100 milliseconds. But for high traffic websites, then Drupal recommends using an external cache. I'll speak a bit about that in a minute. The important thing to note about the full page caching, internal page cache or an external page cache can do, is that it can only cache things that are good to show to everybody. So for anonymous requests, as soon as you have a session involved, then the page cache, that layer of page cache can't continue to serve pages quickly, and this ends up causing more load onto your site, slower experience for users. So that's to be avoided where possible. So everything in LocalGov Drupal is architected fairly well for this. Certainly, like you could imagine things like the alert banners that need to pop up like once for a user, it could be implemented differently, such that like the server has to remember whether or not the user has seen an alert banner, but like through the mechanism it uses with like JavaScript to decide whether to show the alert, and JavaScript storage to record whether or not it's been seen, then the pages remain cacheable and remain fast. Another thing I wanted to mention is a fast 404 module. So whenever somebody hits a 404 error on your site, then it's quite an expensive operation. Out of the box, then it will log this to the database, as well as like bootstrapping a lot of unnecessary things to show an error page. So this module is helpful if you're receiving a lot of traffic to nonsense routes. So I mentioned database logging again. So this is something that that can also put like an undue strain on your database server and slow down requests. So I would recommend using an alternative like the system log module for this. So I wanted to speak a little bit about external caches, and particularly the Fastly CDN we've used. So what are the benefits of having a CDN, a content delivery network, I should say. So some of the benefits are like performance. The idea is that traffic can be routed to a nearby server that's close to the user, which reduces latency. So this isn't the most important aspect of it for a local government site, because you're catering to a very like geographically specific audience. Like maybe you have sometimes things that are international, and it would be helpful for that. Also, it's just a good way to have an external cache that's on a fast network. So when pages are being loaded from a CDN, then it's just a few tens of milliseconds for the users generally. It's also resilience. So like talking about maybe the AI bots again, as Andy was in the facets, and I guess anybody who might want to take down your website. So maybe like disgruntled residents, we've heard of this, or maybe more likely at the moment, politically motivated attacks. A CDN is a good place to implement defense against these kinds of things. Let's say something else. Oh yeah, so I think if you if you're hosting it in a small data center or on premise, then this is particularly important because being able to deal with large denial of service attacks requires having a lot of bandwidth, which content delivery networks, that's what they have. You might be all right if you're on like a large cloud provider, so Azure or AWS, for example, then this is their bread and butter too. So and also reliability. So the if there's a problem with your server, then the CDN can step in and continue to serve cached pages for you, which is good. It means that your information is still available. It might not be able to complete tasks like filling in web forms, which require interaction with the backend server, but I mean, your website's then degraded rather than down, which is a very good option to have. I mentioned it will route traffic to a server that's close to you. They call these points of presence. Most CDNs now, the overwhelming majority of CDNs operate in an origin pool way. So that means that they're just proxies. The traffic will go in, and if it's able to serve it from cache, it will. Otherwise, it will forward the request through to your server. Previously, then you'd have to do things like upload assets specifically to CDN, but that's thankfully a thing of the past. So it will. Speaking from a fast experience, then the way that it can route traffic is using either DNS, and so they've got a magic DNS server that can tell where you're coming from. Well, it's strictly speaking, it's the IP address of your DNS resolver that they can tell where it's coming from. I think there's an extension to the DNS spec that will allow it to know your actual IP address. I'm not sure if that's actually in or not. And also, it can use anycast IP addressing, so there'll be multiple servers with the same IP address. And then the network will route to the closest one. So on Fastly, then they prefer you to use the DNS mechanism. Apparently, that gives you better. It chooses the server more specifically, but it only works if you're able to point your domain at a CNAME. So if you're using like an Apex domain without the www, then you'd have to use the anycast IP method. So why are we using Fastly over other CDNs? So it's obviously like Cloudflare, there's Azure Front Door, I believe, is it? There's Amazon CloudFront. So we've got a long history of using Varnish Cache Server in front of websites as an external cache, and this is what Fastly is based on. So there's A, familiarity with it, and B, this has historically been what Drupal sites choose as a cache layer. So there's a lot of like history of good configuration. So it will just work basically, and you'll note that Drupal.org is on Fastly, which is a good sign. So it's highly configurable using the Varnish configuration language. So that's based on a series of hooks during the request lifecycle. So you can choose to intervene at various different points. So when the request first comes in, or when it's being sent to your origin server, or you can change it after it's come back from the origin server. So you can do things like manipulate headers, you can change the content, you can alter the routing rules, so you can send it to a different server entirely. You can have multiple services behind one Fastly service. So it has a Drupal module, which is good and sets everything up for you, basically. So this means it will go and configure your Fastly service to have the Drupal specific configuration in there, and also it will set up all of the required headers that Drupal needs to emit for the cache clearing system to work, and it hooks into Drupal's cache clearing system. So like when content needs to be invalidated, then it will do it quite rapidly. So I wanted to go into this quickly because this is my favorite part of Drupal. How does it know like what content to clear from cache when you update a page? So for example, if you edit a news article that's live on your site, you might think you just need to purge like the URL of that news article, which is good. So this page has now been updated, but you then look at the news listing page, doesn't work. It's still got the old content because nobody told it to clear that particular page. So with cache tags, every single piece of content that gets rendered within Drupal will have like a manifest, a list of all the composite pieces of content, and through this, then at first these are sent to the CDN with the page response, and then when it comes to clearing the content, then it will clear the list of tags. We say clear that node, and we clear the list of nodes, and then all of the content that includes that piece of content will also be invalidated, and you won't see any stale content. So what's really good with the system is that you can set your cache lifetime to be incredibly high. I think you actually need a patch to be able to set it to a month. This is like taking this from a production site. So the really cool thing is that this is the cache lifetime that's being sent to Fastly, but Fastly is then sending content to users without like with a short cache lifetime, or so don't cache. So whenever a page changes, Fastly is informed, and then users can fetch the content. If it's been modified since their cached version, then Fastly will send them the new version. If not, then they can use their browser cache. And you're basically having your cake and eating it. And nobody sees any stale content, but everything's cached for a long time, and you get high hit rates, which are important for performance. So we had a couple of issues with Fastly, the Drupal integration. So like public files, these were not sending the correct headers to Fastly because they're being emitted directly by our Nginx rather than going through Drupal and getting the right tags on there. We've got a fix in the works for that. We're going to contribute that back. And also we had to make changes to the Fastly configuration to allow large files. I think maybe I'll just forget the section on AI bots since we're reaching time. And should we close it there?
What a tease, Graham. Can you cover it in a minute? It's probably
a
worth
minute. Oh, well, we'll try very quickly.
Yeah, I think it's worth. I think given it's a pretty, yeah.
So, like Cloudflare have got some really good statistics on where bot traffic are coming from. It's worth checking this out if you're interested. We're currently like worldwide, then we're at 33% bot traffic versus 67% human traffic. So it's I think this has gone up by 40% over the last year. So you can see sort of where these are coming from. These are the autonomous systems, which are sort of groups of networks. So these statistics include all kinds of bots. This is so like Google bot. You're obviously this has been a thing forever, and Bing bot. But then you have like GPT bot, Meta external agent, or AI crawlers. So particularly like Meta external agent, then we get a lot of requests from that. I went through some statistics last year from our traffic, and that was like the #1 user agent on our sites. So there are a couple of different flavors of AI bots that you'd be aware of. So there are those that are just sort of crawling to get content. I imagine this is to train a model. But these are the ones that we've seen a lot of problems with hitting links in facets in LocalGov directories. There's another kind as well, which comes into play when a user has a specific query, and then the AI will call out to the bot to go and fetch a page from your site to try and answer it. So we see a lot of problems with that as well, because particularly the GPT user bot will go after PDFs to extract information. And these can be quite large, so it's wasting a lot of bandwidth putting in obscure PDFs to try and answer somebody's questions. So ways to deal with it. So you can put in robots text if there's a specific user agent that you don't like, then and they are a well-behaved one, then you can ask them not to, or you could set a crawl delay to slow them down. And also, particularly through Fastly, there are good options for blocking traffic. I mean, sometimes it's quite difficult to ascertain where traffic has come from. You can see it's the same bot, but it's coming from different countries, different IP addresses. It's using randomized user agents. There is a thing called like TCP fingerprinting, like JA4. It's called, which can hash the client handshake basically, and that's an extra way to try and disambiguate who somebody is and whether you want them on your site. And so I think we'll leave it there.